Hello friends, welcome to the Another Space channel. Our universe is an enigma. An endless, inexhaustible paradox. It's largely a dark, cold and lifeless ocean. But within this ocean, there are islands, blazing with light, galaxies, trillions of them, each one home to hundreds of billions of stars. And around many of these stars, there are planets, alien worlds, each incomprehensibly strange. There are trillions of planets in our universe, and one of them nurtured beings capable of contemplating this cosmic drama, miraculously improbable. Brief candles flickering against the eternal night. As darkness begins to fall, if you know that all those points of light that appear one by one in the darkening sky are distant suns, then it's impossible not to be overwhelmed at the sheer scale and majesty of it all. The universe is infinite in all directions and terrifying in all directions. But if you can overcome your fear, then questions arise. And surely the most profound question of all is, how did all this come to be here? That's a question that's defined much of human history. But it's only in the last century or so that we've had the intellectual and technical tools to interrogate nature directly in search of an answer. And we found that it looks for all the world like there was a first moment in time, a beginning to the universe 13.8 billion years ago, the Big Bang. For all the world, but not quite. Because we've begun to suspect that there's more to it, and we've embarked on a heroic quest to search for and to explore the time before the dawn.
For all the people back on Earth, the crew of Apollo 8 has a message that we would like to send to you. In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light," and there was light. And God saw the light, that it was good.
Since we first became conscious of ourselves, we've looked to the heavens, to those mysterious lights. Searching for answers. What is the universe? How did it come to be? And what is our place in the cosmos? We sometimes doubt the creation stories that our ancestors told. But those ancient myths conceal a profound truth. The clues to the origins of everything can be found out there, in light which ripples to us from beyond the stars. If we're going to dare to know about the origin of the universe, then we have to have some evidence. And the connection we have with the deep past is light. See, light travels very slowly on the universal scale, only 186,000 miles a second. It takes light 8 minutes to journey from the sun to the earth. It takes 4 years to light to journey from the next nearest star. And that means we see that star as it was 4 years in the past. So the further out into the universe we look, the further back in time we look. And because we can look into the distant universe, we can look back towards the beginning of time.
Go ahead, Charlie.
Everything is good, and we are starting the next stage.
Okay, Charlie.
In the quest to find the origin of the universe, we need a time machine. A telescope so powerful that can peer out so far into the universe that it can capture the most ancient light. And carry us back towards the dawn of time. The Hubble Space Telescope has taken us on an odyssey through the universe, revealing its gods and monsters. Our universe is a place of beauty and terror. Hubble has shown us visions of sublime creation and images of awesome destruction, illuminating our journey backwards in time towards the dawn. The Orion Nebula, a stellar nursery, clouds of gas nurturing newborn stars in the Milky Way, an image brought to us by light that left the nebula 1,300 years ago. The pillars of creation, towering, delicate structures, light years tall, 7,000 years ago. The Andromeda Galaxy, a glittering island of 1 trillion suns, 2.5 million years ago. A cosmic rose, galaxies colliding in a celestial dance. 300 million years ago. But Hubble's voyage has taken us even further out into the uncharted ocean of space, ever deeper into the darkness, glimpsing countless ancient and faraway galaxies, glimpsing countless ancient and faraway galaxies, wild and primitive shoals of stars, lighting the way to the primordial past, until finally Hubble approached the farthest shore. A galaxy near the dawn of time. This is a galaxy called GMZ 11, and it is one of the most distant galaxies we've ever seen. This is light from some of the first stars in the universe. It began its journey only 400 million years after the Big Bang, and it's taken 13.4 billion years to reach us. And think about that. This light journeyed through the universe, and after 9 billion years of its journey, the Earth formed. And then, during the whole history of our planet, it completed the last third of its journey and entered our telescopes. So this is an image from the edge of time. GNZ 11 was one of the very first galaxies, formed at a time when the universe itself was taking shape. Shortly after the Big Bang, GNZ 11 was a strange galaxy by today's standards. "25 times smaller than the Milky Way, but filled with enormous, violent stars. Lurking alongside these volatile giants, there were other things. Delicate objects struggling in the maelstrom. Some of the first planets in the universe. These were strange primordial worlds. And over the horizon of one of them, a sun rose, marking a new chapter in the history of the universe, the beginnings of a relationship between stars and planets that would, billions of years later, on a faraway world, lead to the origin of life. Now, we don't know when or where the first dawn broke in the universe. But what we do know is that the first dawn was not the first moment. The stars and planets had to come from somewhere. So the first dawn was preceded by a long, dark night. Astronomers call this era the cosmic dark ages. If we continue to journey back in time, we'd see shadows fall across the universe. The galaxies would disappear. The first primitive stars would be extinguished, one by one, and darkness truly would be upon the face of the deep. Here, in the impenetrable gloom of the cosmic dark ages, our quest to understand the origins of the universe would seem to end. So how can we peer into the cosmic dark ages to explore the origin of the universe? Well, perhaps counterintuitively, the light from the stars can still guide us, because that starlight has been travelling across the universe for millions or even billions of years to reach us. And information about the way the universe has changed and evolved becomes imprinted in that starlight. The stars have illuminated our voyage through time. But their light can't guide us directly across the dark ages. Instead, their light can be used to build maps of the universe, in space and time, that allow us to navigate towards the moment of creation. And the most valuable light of all comes from very particular stars in the spectacular swan song of their lives. Stars exist in a permanent state of conflict because the force of gravity is relentless. Left to its own devices, it will crush anything and everything without limit. But fortunately, other forces come into play. As the star collapses, its core heats up and turns into a giant nuclear fusion reactor. Hydrogen is converted into helium. That releases energy, which creates a pressure which holds the star up. But stars like our Sun burn hundreds of millions of tons of hydrogen into helium every second. And although they are big, they're not infinite in size. Stars, just like human beings, have a lifetime. They are subject to the relentless march of time. Now, for stars like our Sun, the collapse continues until it produces a new and exotic type of star, known as a white dwarf. White dwarfs are strange beasts. The fading remains of stars, super dense, planetary-sized cores, usually composed entirely of carbon and oxygen. Stars that were once 1,000,000 times the size of our planet, crushed to the size of the Earth, subjecting the carbon to extreme pressures and making white dwarfs, in effect, stellar diamonds. These diamond stars are critically balanced, able to resist the relentless inwards pull of gravity, but only just. In 2018, Hubble was in orbit. The telescope focused on a galaxy far, far away, hunting for a distant white dwarf that we knew was coming to the end of its extraordinary life. For millions of years, the white dwarf had remained hidden, locked in orbit around a much bigger star, a red giant. As they circled each other, the white dwarf's gravity drew in gas and plasma from the red giant. The mass of the white dwarf increased until it approached a critical limit. Known as the Chandrasekhar mass. And surpassed it, triggering a colossal thermonuclear reaction. The white dwarf detonated in a gigantic explosion called a supernova that millions of light years away was detected by Hubble. That white dwarf star, or to be more precise, the supernova that it became, has a name. It's called SN 2018 GV, and even though it is 70 million light years away, it is so bright that we could make a movie of it. I mean, imagine that. This is a star the size of the planet, ending its life with a flash of light that's as bright as 5 billion suns. Now, although supernovae like these only shine for a few days, they cast a profound light out across the universe. We've given a name to the sort of supernova Hubble saw. They're called Type 1a supernovae, and they're common enough to allow us to map the evolution of the universe. Type 1a supernovae really are nature's gift to us. Because they all explode in the same way, that means that they all shine with the same brightness. And that means that if we see one that's dimmer, it must be farther away, and that allows us to measure the distance to the galaxy that contains the supernova. And because they shine so bright, we can see them tens of billions of light years away, that means that we can measure the distance to galaxies all the way out towards the edge of the observable universe. But there's other information encoded in the light. When we look at the light from distant supernova explosions, we see something very interesting and very surprising, because the light from every single supernova that's not in our neighbourhood is redder than it should be. And the further away the supernova, the redder the light. It's called a redshift. Now, light has a wavelength, and the longer the wavelength, the redder the light. So the explanation is that during the time the light has been travelling from the supernova to us, space itself has been stretching, and that's stretched the light. And that means that the universe is expanding. In our quest to find the origin of the universe, this is a vital clue. Because if the universe is expanding today, then tomorrow everything will be farther apart. And it follows that yesterday everything was closer together. So if we want to understand how it all began, we have to wind back time through billions of yesterdays. We have to go back to a time before the Earth and Sun. To a time before the galaxies. And all the while, the universe is shrinking, getting ever smaller, denser, and hotter, until we arrive at the most famous moment in the history of the universe. Our universe is a place of infinite variety. There are galaxies of exquisite beauty, stars of stupendous power, there are planets, countless brave new worlds. Galaxies, stars and planets are the things that make our universe remarkable. They are the things that make it more than a barren expanse. How did a universe of light and life emerge from the cataclysm of the Big Bang? Unfortunately, we don't know. We don't even know if the universe had a beginning, but we do know a great deal about how the universe evolved from a very different state a long time in the past. We know that 13.8 billion years ago, this space that I'm standing in now, and the space you're standing in now, and all the space out to the edge of the observable universe containing 2 trillion galaxies, was very hot and very dense, and has been expanding ever since. Now that implies that way back, everything was closer together. Everything was contained in a very small speck. But how small was that speck? How did it come to be? Well, we used to think that the universe emerged in that state, very hot and very dense at the beginning of time. And we used to call that the Big Bang. But now we strongly suspect that the universe existed before that. And in that sense, it's possible to speak of a time before the Big Bang. So what was the universe like before the Big Bang? The first thing to say is that it was very strange. There was no matter. All that existed was space-time and energy, an ocean of energy, almost still, but gently rippling. Before the Big Bang, the universe was a cold, alien, featureless place. Picture it as a near-still ocean of energy filling the void. Although it contained no structures, that energy did have an effect on space, caused it to stretch. Not that gentle expansion we see today, but an unimaginably violent expansion. That expansion is known as inflation. Think of a speck, a tiny, insignificant patch of space. Insignificant, except that many billions of years later, this speck would have grown to become our entire observable universe. The speck expanded at a phenomenal rate. An exponential expansion that lasted for just a few billionths of a second. Now the speck continued to expand until it was about the size of this cave. And then inflation drew rapidly to a close. And all the energy in that ocean that was driving the expansion was dumped into space and formed the ingredients of everything in our observable universe. I mean, imagine that. A space about this size filled with enough energy to form 2 trillion galaxies. That's what we call the Big Bang. So the Big Bang was not, as we commonly mention, some kind of explosion. It was actually a transformation of energy into matter. And the fossilized remains of these momentous events, the memory of the rippling ocean of energy that drove inflation, became imprinted into our universe. In fact, these fossilized ripples shaped our universe, influenced where each galaxy and star emerged, each planet and moon. But how do we know all this? How do we know that there was a Big Bang? How do we know that there were ripples in an ocean of energy before the Big Bang? The answer is
liftoff of Space Shuttle Atlantis. Final visit.
Planck scanned the entire cosmos, looking for light. Not light from galaxies or stars, but light from the beginning of time. This is a photograph of the distant past. It's the most ancient light in the universe. This is light that's travelled for almost 13.8 billion years to reach us. It's a photograph of the entire sky, a celestial sphere, if you like, every direction that we can look, and it's been laid flat so we can see it all. It's called the cosmic microwave background radiation, and it's an almost featureless glow. There are no stars and no galaxies in this universe. Now, you might ask the question, well, if there are no stars and there are no galaxies, then where's the light coming from? The answer is the light is coming from the universe itself. Because this is only a few 100,000 years after the Big Bang, so the universe was hot. So what you're seeing here is the afterglow of the Big Bang. The most revealing thing about this picture is the detail. The variation. This pattern is one of the most important discoveries in all of human history, because it represents one of the necessary steps in the story of how we came to be here. That still ocean of energy that drove the rapid expansion of space during inflation could not be entirely still. There had to be ripples in the ocean. It's a consequence of the laws of nature as we understand them. And those ripples in the ocean were imprinted into our universe through the Big Bang and emerged as those areas of slightly different density in the young universe. And then as the universe continued to expand and cool, the regions that were slightly denser collapsed to form the first stars and galaxies. So without those ripples, we would not exist. But there's one more extraordinary thing about these ripples, and that's the fact that we predicted them before we knew they existed. And then we ventured into space to test our theory Planck's observation of the afterglow of the Big Bang is strong evidence for our outlandish creation saga. The story of the speck, the ripples, and inflation. These ripples, then, are the seeds of our creation, and we dared to guess that they exist. From our vantage point here, on a small planet 13.8 billion years after the moment of creation. And then, because we're scientists, we decided to launch a spacecraft out into space and capture the oldest light in the universe. And we saw that our guess was correct. We dared to imagine a time before the dawn, and we proved that our creation story is not a myth. So here is the creation story, as told by science. In the beginning, there was an ocean of energy that drove a rapid expansion of space, known as inflation. There were ripples in the ocean. As inflation ended, the ocean of energy was converted into matter. At the Big Bang, and the pattern of the ripples was imprinted into our universe as regions of slightly different density in the hydrogen and helium gas that formed shortly after the Big Bang. The denser regions of gas collapsed to form the first stars, and the first galaxies, and the first galaxies. And 9 billion years later, a new star formed in the Milky Way. The Sun. The star was joined by 8 planets, including Earth. And nearly 13.8 billion years after it all began, we emerged blinking into the light.
To see the Earth as it truly is, small and blue and beautiful in that eternal silence where it floats, is to see ourselves as riders on the Earth together, brothers on that bright loveliness in the eternal cold, brothers who know now they are truly brothers.
We all have moments of wonder. We all dream. Our thoughts float free, soaring across the earth and out into a canopy of stars. In our most reflective moments, I think we all understand that, small though we are connected to the universe. We are collections of simple atoms, but atoms arranged remarkably, with the urge to explore the universe and to comprehend it and celebrate our own place in this great cosmic saga. And if we follow that saga back, it takes us on a pilgrimage to a time before the dawn and to strange ripples that existed in a universe before our own. I think we all must wonder about the meaning of it all. What does it mean to be human? Why do we exist? Why does anything exist at all? But these do not sound like scientific questions. They sound like questions for philosophy or theology even. But I think they are scientific questions because they're questions about nature. They're questions about the universe. And the way to understand the universe is to observe it. And we've seen ripples in the most ancient light in the universe laid down by events that happened before the Big Bang. We've seen billions of galaxies written across the sky in a giant cosmic web. And we've seen thousands of planets orbiting around distant stars, worlds beyond imagination. But the lesson to me is clear. We won't answer the deepest questions by being introverted, by looking inwards. We will answer them by lifting our gaze above the horizon and looking outwards into the universe, beyond the stars. We used to look to the sky and see only questions. Now we're beginning to see answers.